Hello. In this video we are going to learn about suppository. Let's get started. These are the contents that we are going to cover in this video. First of all comes the definition. A suppository is a solid dosage form that is inserted into the rectum, vagina or urethra where it dissolves or melts and exerts local or systemic effects. It is mainly used for pediatric and geriatric patients, means of children, and for people at older ages. It is mainly used for children and people of older ages. And the suppositories are in bullet shaped. These are medications of bullet shapes which are inserted into the cavities of our body and where it melts and exerts its effect. When it melts, the medication comes in the contact with our body and it exerts its effect. Now you can see the suppositories in the figure which are bullet shaped, and these bullet shaped suppositories are prepared inside the suppository mold. These are the suppository molds which contains these holes. Inside the holes the liquid medication is inserted, and when it solidifies it converts into these bullet shaped suppositories, and this is the way how the suppositories are inserted into the body cavities. Here comes the composition of suppository. It mainly consists of base and drug. Base is the substance in the medication that supports the drug, and here in case of suppository the base forms the major part of the composition. Base is in higher amount than the drug. Common examples of bases that are used to form a suppository are cocoa butter and PEG, that is polyethylene glycol. Then comes the drug, which is the main component and shows the systemic effect inside the patient body. The common examples of drug that are used in suppositories are iodoform, glycerin, and many more. Let's talk about the displacement value. First of all, I want to discuss the definition of displacement value. Displacement value can be defined as the volume of drug that displaces 1 gram of the suppository base, and the most commonly used suppository base is cocoa butter or theobroma oil. It is a numerical value which is used to calculate the actual base which will be required to form the suppository. What happens that the actual base required to form the suppository is much lower than the theoretical base. From the conceptual part we can calculate the amount of base that will be required to form the suppository, and that is called the theoretical base. And another one is the actual base which will be required in the practical use. Let me describe the difference between the theoretical base and the actual base. Now you can see I have drawn these molds. These are the suppository molds that I have drawn, and first of all let me tell you that the yellow color indicates the base and the gray color indicates the drug, and the capacity of this mold means the amount of medication this mold can hold is 2 gram. This is the maximum capacity of this mold. Now let me describe how the theoretical base is different from the actual base. From the capacity of the mold we can calculate the amount of base we'll be requiring. Now the mold contains 2 gram of the base. This is the theoretical amount of base that will be required. This is the theoretical amount of base, but the actual base required will be less than the theoretical base. When we will add the drug inside this mold, then some amount of this base will displace out. Let's take an example that when you will put a stone or a pebble in a glass full of water, then some of the water will fall out from the glass. Similar happens here, where the drug replaces some of the base. What I am trying to say that when we will add the drug, some amount of the base will be replaced by a drug. So some amount of the base will be replaced by a drug, and the amount that is replaced has to be calculated using the displacement value. And how we will do that, I will describe it right now. So now let me give you an example with the help of which we will understand why the theoretical base is different from the actual base. So here is the example. So at first we calculated that this mold contains 2 gram of base. So this is our theoretical base. But when we will add 0.5 gram of drug, or any amount you want, 0.5 or 0.7, here I have taken 0.7 gram of drug. So when we will add 0.7 gram of drug, then the total suppository weight will be 2.7 gram, which is much more than the capacity of this total mold. So it cannot happen, which is more than the capacity of the mold. So this cannot happen. So some amount of the base has to be replaced by the drug. So now our drug is 0.7 gram, and the total base, that was the theoretical base, was 2 gram. After adding the 0.0 gram of drug, so that amount of the base will be replaced by the drug, and the actual base comes out to be 1.3 gram. And now this thing perfectly accommodates the whole mold of the suppository. So this is how the actual base is different from the theoretical base. The theoretical base is always higher than the actual base. So when we will sum up the theoretical base with the drug, the total amount of suppository will exceed the capacity of the mold. But that will not happen. Some amount of the base will be replaced by the drug, and there comes the displacement value, by which we can calculate the actual base that is required to form the suppository. So the amount of base displaced may vary with the density of drug. Now consider these two as suppository mold of equal capacity containing same amount of base. Now when we add drug in each of these molds of equal weight but of different densities. As you can see in this figure, this suppository mold contains the drug of less volume but with a higher density. From the formula we know that density equals mass over volume, where density is inversely proportional to volume. So the drug with larger volume will displace much more of the base than the drug with a lesser volume. So this drug will displace much less amount of base than this drug. Maybe both are having same amount of weight, but the displacement of the base depends upon the volume of the drug. So the amount of base displaced may vary with the density of drug. The conclusion is that the drug with lesser density will displace much more base than the drug of higher density. So now comes the calculation, how to calculate. So now at this point you are very much familiar with the actual base, what is actual base, what is theoretical base, and displacement value. So from that we can derive an equation, or you can say a formula, that is actual base required is theoretical base minus total amount of drug over the displacement value. So from this formula you can get the actual base required, the displacement value, and also the theoretical base. So in the next video I will try to show you some mathematical problems regarding these suppositories. Till then, subscribe to my channel, check out the previous video, do like and share this video. Stay healthy, bye.